Hello guys, in today's video we'll see non-singular matrices. Okay, so what is this is somewhat a bit different when compared to the other echelon canonical forms, but the procedure still remains the same. I mean those operations and all. So look at here. First they'll give you a matrix and they'll say this matrix is in the form of canonical only. Okay, then you have to find the p and q matrices which are non-singular. That means if you observe, whenever you are doing the echelon form or canonical form, you will get the 0 rows. That means you'll have 0 rows here, and you'll get sometimes singular matrix, that means that A equal to 0. So here they are asking us to find non-singular matrices, that means whose det is not equal to 0, and when you perform row and column transformations on those P and Q matrices, you should get this matrix again. So how we know that there are two matrices, and if you just randomly put the numbers, it's not at all possible, right? You have to multiply the values and then you have to check exactly all the values should match to this one. How? See, first what you have to do is take the A matrix. It is in the form of canonical form, right? Canonical form means what you will get? Identity matrix. So whatever the matrix you multiply with the identity matrix, it will be the same again, right? So now we have to take I matrix. So we took I here. Then what about the order of matrix? That means you should take 3 by 3 or 4 by 4, or what is that? So it is dependent on the question only. If the question is 3 by 3, take the I3 matrix. If the question is 4 by 4, take the I4 matrix. So okay, now I3 A I3. Okay, this is the format, most important formula. Okay, this based on this only we'll get the non-singular matrices. Now what you have to do is you will write this I matrices and the A matrices here. You will perform operations on the right hand side, and you will equate those to the left hand side. Okay, so what is the method, or what you will do is, first write the A matrix on the left side. 1 0 minus 2 2 3 minus 4 3 3 6. Okay, now equal to, what is the I matrix? 1 0 0 0 1 0 0 0 1. Write A as it is, and again 1 0 0 0 1 0 0 0 1. Now you will see, here we have identity matrix, here also identity matrix, and here we are just keeping it as A. Now how you will say that particular solution we have achieved? That means, see, you should use same row and column operations only here also. So using those row and column operations, you have to make this matrix as identity matrix. Okay, so generally what we will do is we will write A this side, and we will make this side matrix as identity matrix in general. But when we are finding the non-singular matrices, what you have to do is you have to make this matrix as 0. I mean identity matrix, that means 1 0 0 0 1 0. So this matrix as identity matrix, and this, what about this? These matrices are already in the identity only. Then what you should do is you have to perform the same operations here also. That means in order you are making this matrix as identity, right? So for example, you have used row operation, like row is equal to row 1 plus row 2, row 1 equal to row 1 plus row 2. So you will do this. So you are making zeros here. So whatever the operations you are doing here, do the same operations for these two matrices also. That means you have to perform row 1 is row 1 plus row 2. Again for this also same thing. Okay, now once this identity matrix is achieved, whatever the matrices we get here, two matrices, those are non-singular matrices. That means P and Q. Now first what we will do is R2 minus, for this matrix, what I said, first take this one, make this as zeros, and then this as zeros, and then this, then this. So you have to go in the same way, only then you will get the solution very quickly. Okay, now first I will do, what I will do is R2 is changed with R2 minus 2R1, and R3 is updated with R3 minus 3 R1. Now what you will get here? 1 0 minus 2 0 3 0 0 3 0. Okay, now you have to use the same operations again on this side also. These operations I performed for this matrix. Okay, this matrix. So when you use these operations to this matrix, you will get this. So use the same operations for this and this matrix, you will get the two matrices again here. So what are those two matrices? We will solve. We will get 1 0 1 0 0. We are changing R2 only, right? So minus 2 1 0 and then minus 3 0 1. So if you practice more, you can just see those rows and you can just directly write the answer. Okay, you don't have to do all the calculations here. So it just needs some time and practice. Okay, you will get 1 0 0 0 1 0 0 0 1. Yeah. So we have completed this. Okay, now what you have to do next is, I guess I missed one point saying here. So here A, right, you got Y. Okay, the same operations we are performing on the identity matrix, but why we got here 2 3 and why it's still the same is I missed one point here. So whenever you are performing row operations, for the row operations you have to work on this matrix. For the column operations you have to work on this matrix. I thought I said this point. Okay, I'm saying it now again, because I wrote, just by practice I just wrote this 100 zeros, and now the point is, whatever the row operations you are doing for this matrix, do it on the first matrix. Whatever the column operations you are doing for this matrix, do it on the second matrix. Okay, now we have made this zeros, and here zeros also, we got here also zeros. Now what we can do is, we can change R3. Okay, R3 minus, if we do 3 minus 3, we will get the 0 also, right? So these two rows will be zeros. Okay, now what I'll do, R3 is changed with R3 minus R2, and R2 is divided by 1 by 3 R2. Okay, now what we have to do is here, so we will here write quickly the answer. So we are not changing first row, it will be same. Second row we are updating it in the later step. So first we will write R3 row. So R3 minus R2 means you will get 0 0 0. Now for R2, 1 by 3 of R2. Why? Because just to make this as 1, because we have to get the identity matrix, right? So we'll write 0, 3 by 3 is 1, 0. Now we have updated it. Now remember, we are doing this operation after this. R2 is updating after this only, so you can perform in the same step. For example, if you are updating R2 first and then you are writing R3, then do it in separate steps. Okay, you'll be confused again. So 1 0 0. First you have to do R3 minus R2, minus 3, minus of minus 2 is minus 3 plus 2. So you'll get minus 1 0, minus of minus 1 is again 0 minus 1. Yeah, it will be minus 1, and this one 1. R2 minus R2, 1 minus 0, you'll get 1. Now for R2, you should divide, right? Minus 2 by 3, 1 by 3, 0 by 3 is again 0. A, and write this 1 0 0 0 1 0 0 0 1 as it is, because we are not doing any column operations, only row operations we have completed. Now if you observe here, we have achieved this identity matrix, but we have one number as minus 2. So what I'll do is, we can just subtract this and this. No, if you multiply with this column as 2, 2 ones are 2, and if you just add 2 plus of minus 2 is 0 again, so you can make this number as 0. So what we can do is, C3 is updated with C3 minus 2 C1. Okay, you can just update this rows. That doesn't make any difference. If you make this as 0, you should just again multiply this with, sorry, divide it by 2. Again you will get the answer 1 only. So here the same thing, it will not change anything, because we have 1 here and -2 here and remaining elements are 0. Okay, even if you don't understand this, why I did for 3 and it for 1, it doesn't matter. Just try solving it on your own, you will understand. Okay, now what you will get here, we are changing 0 0 0 1 0 0 0 0, and here you should not do any operations here. Why? Because this is column operation, you have to do them on the post matrix, post factor, that means after A. So what you will get here, 1 0 2 0 1 0 0 0 1. Okay, so this is identity matrix. We have achieved, right, identity matrix. So what is this? 2 by 2. Okay, I2 matrix, right? So that means rank is 2. Sometimes even in the question they'll ask you to find the non-singular matrix, and then they will ask you what is the rank. So you don't have to perform again extra steps. So once you get the identity matrix, whatever the matrix order is there, that will be the rank of the matrix, and whatever the matrices obtained here are P and Q. So P is one non-singular matrix, Q is also one non-singular matrix. Remember, okay, I'm just telling it you all the complete procedure at once. First you have to, whatever the question they gave, check the order of the matrix, write those order identity matrix here. Okay, after writing that, write A, that means given question, on the left hand side, and don't write it on the right hand side, just as we do. After that, whatever the row performations or column transformations are you are doing, make sure you perform them on the left hand side matrix along with the identity matrix. But there is one more condition here. For row, if you are making any row transformation, you have to perform those transformations only on the first matrix, which is called as prefactor matrix. Okay, and if you are making any column operations, you have to perform those column operations on the second matrix, that is post factor matrix. Okay, up to where you have to complete this procedure is, unless you get identity matrix in the left hand side. Once you get the matrix, identity matrix in the left hand side, whatever we got in the P and Q, identity matrices places, those are non-singular matrices, and whatever the identity matrix we have obtained, that will be the rank of the matrix. This is the important question. Okay, this is very important. You'll get this question also. Okay, so this canonical form, echelon form, non-singular matrices, skew, symmetric, so all these are very important. We never know in which section they'll ask, but they'll maximum include all these topics in the question paper. So for 2 and 3 marks questions, they'll include skew symmetric, Hermitian and skew Hermitian, and also sometimes echelon form with the easy values. And for the 10 marks question, they will give this non-singular matrices and canonical form, and there is one more question, linear algebraic system equations. So that is also similar to this only, that is not so tough. So these will be the questions, and we will see the system linear equations in the next videos, and try practicing more questions for this chapter. Okay, this is very easy chapter only, that's not too hard. And if you have any doubts, or if you're not understanding what I'm saying, please let me know in the comment section, so I'll try making explaining it in the other way. Okay, and that's all for this video. Thank you.